All right, so for the example, we're given a set of data for the stats teacher believes their students spend how many minutes of time their students spend on homework every night, and they think it's greater than 35 minutes. Okay, so they're going to randomly select 10 students and then record the number of minutes spent on homework last night, and then the data came out below. Okay, so here's our 10 students and how many minutes they spent on homework the night before. Okay, so they're asking, is there convincing evidence at a 10% significance level of this teacher's belief? Okay, so we have a null, okay, and we're going to have an alternative. Okay, so the teacher believes that they're spending more than 35 minutes. Okay, so that means they believe that it's more than 35 minutes, but the claim is that the mean is going to be 35 minutes. Okay, but they believe that it's greater than 35 minutes. Okay, and then we're going to have an alpha of 10. Sorry, let me do that again. 0.1, right? Because we have a 10% significance level, that's our alpha. Okay, so we're in order to calculate, we got a couple of things we're going to need. Okay, so we're going to need an x bar, we're going to need an s, and we're going to need, let's see, n we can find. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 people. And then we're looking for degrees of freedom, which is just going to be n minus 1, so we got 9. Okay, so now to find these other two pieces of information, we're going to have to throw everything in our calculator. Okay, so go to your list, put that data in your list, then go to stat calc, one variable statistics, hit enter, and then here is our information. Okay, we need x bar, 42, we need our s, which is 11.508, I'll go with that, 11.508. And then that's all we need. Okay, that's all the numbers we need. We won't need our calculator again until the end. Okay, so check our conditions. Okay, so is it random? Let's see, randomly selected. Okay, so sample was random. Okay, is it independent? All right, so this is going to be like sort of you got to think on a like typical high school. Like maybe this teacher is teaching, like instead of me with one stat class, maybe they've got 5 or 6. So we're going to have to say that we're just going to say it's a safe assumption. So because it'd be 10% of all stats students. Okay, and it should be like what that the teacher teaches, but this one, like I would argue that on a typical high school, they would have more than 100 students, okay? So I would say that's a safe assumption. If you don't agree with that, then make a note of it, and then in your conclusion, just state why you think your answers might be a little unreliable, okay? Because maybe you disagree with it passing the independent check, okay? So let's see, is it normal? Okay, so let's see, because n's less than 30, okay, and we don't have any information about the population, we're going to graph, so we will graph. Okay, and just do a quick sketch. All right, and let's see, let's go start at 20, we'll do 30, 40, 50, keep moving a little bit, 60, and 70. All right, and then on the y-axis, we'll do 1, 2, 3, and 4. Okay, and then this is going to be minutes studied. Okay, so we had one person, or I'll change to a different color to make it a little easier. One person between 20 and 30. We had 4 people between 30 and 40. We had 3 people between 40 and 50. And then we had 1 for 50 and 60 and 1 for 60 and 70. Okay, so I would argue, so there are no outliers or strong skewness. Okay, so proceed with t-test or something like that. Okay. All right, so because we don't see any evidence of it not being normal, we're going to proceed with the t-test. Okay, and of course we have to state, hey, it's a one sample t-test. Okay, And then that means our statistic, our test statistic, is going to be x bar minus mu naught over s divided by square root of n. Okay. And when we replace all that, we plug everything in. X bar we had was 42 minus mu naught, which is 35, over s, 11.508, divided by the square root of n. Okay. Throw that in our calculator, and we end up with 1.924. Okay. So that means if we need to, okay, let's graph it out a little bit. So that means our t is over here at 1.924, zeros here, and we want to be everything over here. Okay, because we want to be greater than. Okay. So that means we're going to use, and this is where we're going to be careful. We've used normal CDF up to now, okay? But since this is a t-test, we can no longer use the normal distribution. We're using a t-distribution. So we have to make sure in our calculator, we go to t-CDF, okay? All right, so we're not using PDF, or we're not using normal anymore, sorry. Okay, but it works out the same way. You're going to type everything in exactly the same. We have our lower boundary at 1.924. We have our upper boundary at positive infinity. And then our degrees of freedom we have to add in, and that was 10 minus 1 was 9. Okay, then we hit enter. Okay, and this is going to spit out our p-value, okay, which is 0.043. Okay. All right. So then, conclusion. So because our p-value is less than alpha, which was at 0.1, okay, we can reject the null because we have convincing evidence that the average number of minutes a student spends on homework each night is greater than 35 minutes. Okay. All right, so that is the big chunk of this question done, but now part B says to describe a type 1 and type 2 error in the context of the problem above, because again, we haven't talked about error in a while. Okay, so we have HA, HO on this side for our decision. We have HO, HA for the truth on the top. So type 1 is here, this is power, and then type 2 is here. Okay, so type 1 means we are going to reject the null when we shouldn't, okay? All right, which means we're going to think kids are spending more than 35 minutes when they're not, when they're spending an average of 35 minutes, okay? So type 1, okay? Which in other words, we are rejecting the null incorrectly, okay? Says we think that students are spending more than 35 minutes on homework when they're not. Okay, and then type 2, okay, means we're failing to reject the null incorrectly. If I could spell, there we go. Okay. This is saying, okay, so we're failing to reject the null incorrectly, okay? Which means we think they're spending 35 minutes when they're not, when it's greater. Okay. So saying we think they're spending 35 minutes on homework when it's really greater than 35. All right, so there we go.